Now I want to show you how to make a triangle-based pyramid or a tetrahedron using a circle of paper, clear tape, a pen or pencil, scissors, and what I use to make this size of a tetrahedron is just an old CD. So what you need to do is cut out your paper circles. So what I do is I take the CD and I take just regular copy paper, place the CD on the paper and trace around it. And if you're careful with the way that you do it, you can actually put 3 different CD tracings on the one piece of copy paper. And then I put 3 or 4 plain sheets behind that, put paper clips on here just so that it doesn't slide, and then use your scissors just to cut around. Once that's done, and you've got your stack of paper circles, you just are basically doing origami. And one of the nice things about using a circle for folding figures and models is that it has infinite lines of symmetry. So it's pretty easy to do. So the first thing you do is to remember to think of your audience. I've done this from probably about grade 2 and up. And so with grade 2, you're going to need to use different language that you do with grade 6. Even if you're not doing your geometry unit, just think about the words that you can use to reference and review concepts that might be new to them or might be just a review for them. So the first thing you do is you take your paper circle and you fold it in half. And the easy thing with this is that you don't have to match up corners and things, but you do have to match up the edges. But it doesn't matter whether I fold it this way or this way. So once we've got it folded in half, then you can talk about semicircle. I neglected to mention circumference, you can talk about as well. So we've got your half circle, and what we need to do is find the midpoint along the straight edge here. And the way that you do that is take this part here and match it over here, and you just do a pinch. You don't do a full fold on this one. You just want to find out where that center point is. And so that you can see that better, put a little mark there. So then what you need to do now is take this half circle and fold it into 3 equal parts. One of the things I tell the students is that you're going to be making a piece of pizza or an ice cream cone. So what you need to do is fold this over, but make sure that you're folding here, not over here and not here, but you're folding it here. So I use my thumb to help me. So what I need to do is I have to eyeball that this distance from this edge here to here is about the same as this distance from this edge here to here. And then I take this edge here and I fold it to the back. So now you have your piece of pizza. So you open it up, and now what I've got is my circle is now precisely divided into 6 equal portions. What I'll do here is I'll make marks here where the lines meet the circumference and the center point. So what we're going to do is take one of these marks, it doesn't matter which one you do first, and I fold that into the center. So I fold that in, I don't go beyond it, just right to the center. What I tell the children is I tell them to take their finger and run around the circumference till they get to that next mark. And then I'm going to fold that mark in here. The goal is you're going to be making a triangle. So the part here needs to be a very sharp vertex. So I'm going to fold that in here. The kind of problems you'll get is children will go a little bit too short and that'll be flat there, or they'll go a little bit beyond. But if you've got these marks here, usually they're pretty good. And then I take this last one here and I fold that one into the center. And I've now produced an equilateral triangle. Talk to the children about what an equilateral triangle is, how many vertices, how many sides, etc. But the interesting thing is that you've just taken the properties of the circle and made something fairly precise. If they had to fold an equilateral triangle out of just any shape of paper, you would be measuring, you'd need a protractor, you'd have rulers and all sorts of stuff, but that's one of the magic things about a circle. So now you've got your equilateral triangle, and here you can really use a lot of geometry review. Make sure that the folded flap things, those are facing up. There are fold lines here that show the exact midpoint of each of the sides. So I'm going to take one of the vertices and I'm going to fold it to that midpoint. Then you can talk to the children, what shape is that? Of course it's a trapezoid. Then you take the next one and you fold it over this way. What shape have you got now? You've got a rhombus or a diamond shape. Often younger children will say a kite shape. And then we take our last one and fold that one over. I've now got a smaller version of the equilateral triangle so that when I fold it up, I now have my original equilateral triangle, but there are 4 smaller ones here. And then the older children, you can talk about how these triangles are similar to the bigger triangle. Now, just by folding, I have 4 equilateral triangles that are the exact same size and shape. They're all congruent. And you can show the children how just by folding up your triangle flaps here that you can make your tetrahedron. And one of the tricks to taping this well is to take your clear tape and on one of the edges put half of the tape, and then take your side here and line it up as precisely as you can and just sort of fold it over. And then you do that on all three sides, and then your tetrahedron is complete.